Assalamualaikum, hi guys. So we are going to continue with the next derivatives of trigonal bipyramidal. Trigonal bipyramidal is one of the basic shapes that we learned, where the class for trigonal bipyramidal is AB5. We got 5 bonding pairs. So this is the drawing. You got 2 bond angles here, 120 degree and 90 degree. But right now, when I replace one of the bonding pairs, for example, I replace this one with lone pair, so I will have a new structure which is seesaw. So that's why class for this molecular geometry is AB4E, dan dia punya bond angle kita ada 2. So biasanya kita akan label sebagai alpha dengan beta. So tak jadi masalah lah kalau nak label untuk 2 simbol yang berbeza for both bond angle, for each bond angle. And the next one, sekiranya saya ganti daripada here, saya ganti another one more lone pair, I will have the new shape which is this one, T shape, macam huruf T. Dan bond angle hanya ada satu saja value, sama from here to here or from here to there. And you got 2 lone pairs, so the class will be AB3E2. After that, sekiranya saya remove one bonding pair daripada trigonal bipyramidal with lone pair dekat sini, so I will have the new shape with 3 lone pairs is linear, straight saja. So that's why bond angle here should be 180 degree. Then you got 3 lone pairs here. The class dah berubah jadi AB2E3. 2 bonding pair dan 3 lone pair. And the bond angle is 180 degree, sama macam basic shape linear. So ini adalah derivatives of trigonal bipyramidal. We have 3 of them: seesaw, T-shape and linear. Let's try example 10 where I got SE4. So we are going to count the total valence electron. Se, we got 6 valence electrons, and then 4 fluorine atoms, so you got 4 times 7 valence electrons. The total will be 28 valence electrons. After that, we got the total electrons should be 34 electrons. And next, we are going to determine my central atom should be Se, bonded to 4 fluorine atoms. So you use up already 8 electrons from 4 bonding pairs. The one left should be 26. From 26 electron, each fluorine got 3 lone pairs. And this is the drawing. You already use up 24 electrons. So you got 2 more left. 2 more left saya akan letak dekat tengah central atom, iaitu Se, so you got 0 remaining for the electrons. So right now from this Lewis structure, you got Se is my central atom. Se got 4 bonding pairs, and then lone pair untuk Se kita ada 1 kat sini. So 4 plus 1, the total electron pair should be 5. So the electron group arrangement, the basic shape should be trigonal bipyramidal. And after that, the class already different sebab kita ada 4 bonding pair dan 1 lone pair. It should be AB4E. And the next one, kita ada molecular geometry for AB4E is seesaw, jongkan-jongkit. And then from here, you can determine 2 bond angle. Kita ada alpha, which is less than 120 degree. Dan saya ada beta, which is less than 90 degree. So now I can start drawing my molecular geometry for SeF4. Saya mulakan dengan central atom Se. And the bentuk seesaw. So saya akan lukis dalam 3D. 2 bonding pair in plane. Dan another one more in plane. And then saya ada wedges. 1. Dan saya ada lone pair yang menggantikan dashes. Okay, biasanya kita akan tolak dulu daripada dashes 3D arrangement tu sebab dia duduk kat belakang. Okay, now what's left, saya akan gantikanlah dengan fluorine. So we got 4 fluorine atoms as terminal atoms. Make sure each fluorine got 3 lone pairs. And then now what's left, kita akan label the bond angle. So we got 2 of them. First is less than 120 and the second one is less than 90 degree. Less than 90 degree is from here to here. So I'm going to label this one as beta. And after that, this one to this one, we are going to label it as alpha. So here, the bond angle is less than 90 degree and here, the bond angle is less than 120 degree. So you got the molecular geometry for SEF4. Now, let's try ClF3. For ClF3, I got 1 chlorine, 7 electrons, and then 3 fluorine, which means that 3 times 7 electrons, 21 electrons, and the total will be 28 electrons. My central should be Cl, bonded to 3 fluorine atoms, and after that, you use up already 6 electrons. The remaining should be 22 electrons. After that, we are going to put each fluorine 3 lone pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 16, 18. So, 22 minus 18, you got 4 left. So, 4 ni saya akan letak dekat chlorine as my central atom. So, 4, kita ada 2 lone pair lah. 1, 2. So, in this case, at chlorine atom, you can see that I got 3 bonding pairs and I got 2 lone pairs. Total electron pair adalah 5. So, the basic shape masih lagi trigonal bipyramidal. And then, the class will be AB3, E2. Okay, 3 bonding pairs and 2 lone pairs. And after that, we can guess and predict the molecular geometry is T-shape. And the bond angle should be less than 90 degree. Okay, now I'm going to start drawing my ClF3 in T-shape arrangement. So, saya akan mulakan dengan Cl, bonded to fluorine yang pertama, yang kedua, dan yang ketiga. After that, I got 2 lone pairs at chlorine. And jangan lupa, the rest fluorine atom ada 3 lone pairs. And then, last but not least, you have to label the bond angle. So, from here to here, this is our bond angle. So, boleh je label macam ni sebab saya dah state the value here. Kalau awak tak state the value here, awak kena label menggunakan value. So, settle for this part, ClF3. Let's try one last example, I3-. So, I is iodine, 7 electrons. You got 3 of them. So, times 3, it means 21 electron. And you got the charge, means that plus 1 electron. The total will be 22 electrons. After that, I'm going to choose my central. Kita ada iodine je semua, maknanya sama saja central kita. Ambil je satu, bonded kepada 2 iodine. And I use up already 4 bonding pair electrons. So, minus 4, you got 18. And then 18 saya akan isi di sekeliling terminal atom dahulu. So, 12 already use up. So, minus 12, baki adalah 6. So, 6 electrons here I'm going to put at the central atom around this iodine. So, when I want to draw my Lewis structure, don't forget this one got a charge. So, mesti letak square bracket. Negative is our charge. Now, I'm going to determine the bonding pair around this iodine central atom. You got 2 bonding pairs and 3 lone pairs. So, 2, 3. The total will be 5. The basic shape will be trigonal bipyramidal. And then the class will be AB2, E3. So, we can conclude that the molecular geometry for this class is linear. and the bond angle, only one of it, which is 180 degree. So how am I going to draw my molecular geometry? You just repeat the same structure again. So I will have my iodine and the terminal atom. Don't forget the charge. Straight away nak lukis pun tak apa. And don't forget the lone pairs for each iodine. Each iodine for the terminal atom kita dapat 3 lone pairs. Dan jangan lupa dekat central kita ada 3 lone pairs. So from here, this is my molecular geometry for I3-, but don't forget, last thing you have to label the bond angle, which is 180 degree. So sekarang saya guna value saja, tak jadi masalah. So as a conclusion, you can see that we got 3 derivatives of trigonal bipyramidal, starting from the basic shape. And please remember and try to memorize all names of the shape and with its bond angle. So that's it for this video. We are going to see you in the next one. Bye!